Welcome to Peptide-Proof. Today, we're looking at the advanced clinical data and strategic formulation parameters of the Syn-Ake peptide. Let's get right into it. So, today we're staying strictly within the realm of cosmetic pharmacology. We are hyper-focusing on the nicotinic acetylcholine receptor, or NACHR. This is the exact cellular site where surface-level applications try to influence the muscle activity sitting underneath. Grasping how this receptor works is absolutely crucial if we want to figure out how to successfully relax wrinkles without ever relying on injections. The whole clinical case for Syn-Ake really leans on three main pillars. First up is the acid itself. It's a synthetic, biomimetic tripeptide that's incredibly scalable to produce. Second is its mechanism. It works through a reversible blockade, which means you completely avoid the permanent risks you get with injectable neurotoxins. And third, it has a highly validated dual-action clinical impact that actually goes way beyond standard muscle relaxation. To really appreciate this molecule, we've got to look at where it came from. Researchers over at the Swiss biotechnology firm Pentapharm were taking a close look at Wagler-1. That's a 22 amino acid paralytic peptide found in the venom of the Southeast Asian temple viper. Yeah, actual snake venom. Now, it's amazingly good at paralyzing muscle, but naturally it's a massive, structurally complex molecule that would be ridiculously expensive to mass produce. So, Pentapharm cleverly solved this. They isolated just the bare minimum active sequence. They synthesized a tiny 3 amino acid active pharmacophore and gave it a benzylamide cap. And that became Syn-Ake, keeping the exact receptor binding power of the venom, but at a fraction of the cost. Okay, let's break down exactly how this works in the tissue. Syn-Ake operates by intercepting the signal cascade right at the neuromuscular junction. That's the specialized little synapse where your motor neuron actually talks to the muscle fiber. We can chop this biochemical interception into 4 distinct stages. First, a motor neuron releases acetylcholine into the synaptic cleft. Second, and this is really the magic moment, Syn-Ake steps in as a competitive antagonist. Think of it like sliding a dummy key into a lock. Because Syn-Ake is sitting there, taking up that docking pocket, the actual chemical messengers literally can't get in, so the ion channel stays shut. Without that sodium rushing in, the depolarization process just halts. And that brings us to step 4. The muscle safely relaxes. We're quieting the muscle, not paralyzing it. But here is where the data gets genuinely surprising. A 2024 study out of Yildiz Technical University uncovered what's basically a dual-action anomaly. It turns out Syn-Ake brings some unexpected secondary longevity and defense benefits to the table, stretching way past its primary job of just relaxing muscles. Through some really advanced molecular simulations, the researchers found out that Syn-Ake actually docks with SIRT1, that's a deacetylase heavily linked to cellular longevity, and Syn-Ake holds a remarkably stable binding energy there, specifically negative 9.32 kilocalories per mole. On top of that, it inhibits MMP13, which is a major collagen-degrading enzyme. And it still doesn't stop there. It also acts as a powerful scavenger for free radicals. So essentially, it's neutralizing biological aging factors while it's busy relaxing your muscles. We can actually back those molecular claims up with real-world clinical validation. A landmark 2026 study by Zhu and his team at L'Oreal tested a serum formulation packing Syn-Ake, and they hit some incredibly impressive, statistically significant metrics for a topical product. The numbers really speak for themselves here. The trial saw a 10 to 13% reduction in dynamic expression lines. That's a very solid, realistic win for a topical serum trying to influence muscle activity through the skin. But the real anomaly is the static wrinkle depth. They saw a massive 35 to 69% reduction there. Now, if Syn-Ake was only relaxing muscles, those static and dynamic numbers would be pretty similar. Hitting a 35 to 69% improvement in the resting skin architecture, that proves those secondary anti-collagenase and antioxidant mechanisms we just talked about are absolutely working in vivo. To put all this into a wider industry perspective, we need to look at how Syn-Ake actually stacks up against deep intramuscular botulinum toxin injections, and even other topical peptides like argirellin. The absolute biggest differentiator here is reversibility. Botulinum toxin cleaves snare proteins inside the nerve terminal. It permanently disables neurotransmitter release for about 3 to 4 months until your nerve literally grows brand new terminals. Syn-Ake, on the other hand, relies on transient competitive antagonism. Because it's just competing for the receptor instead of destroying proteins, its effects wear off in a matter of hours as the peptide naturally degrades. That means you entirely avoid the frozen forehead risk, not to mention the 1 to 3% antibody development issue we see in long-term neurotoxin users. which leads perfectly into the brilliant synergistic stack they used in that exact L'Oreal formulation. They mapped out a two-step blockade. They paired argireline, which works upstream inside the neuron to dial down the amount of acetylcholine released in the first place, with Syn-Ake, which is waiting downstream at the muscle receptor to catch any acetylcholine that manages to slip by. The two approaches are totally complementary, not redundant. Now, all this exceptional biochemistry doesn't mean a thing if the peptide can't actually reach its target. The massive physiological hurdle here is the stratum corneum. It's a dense, formidable matrix of keratin and lipids that human evolution specifically designed to keep outside molecules exactly where they are, outside. Because of that, we have to follow some strict strategic formulation rules. Syn-Ake comes in at about 495 Daltons. That means it is riding right on the absolute edge of the 500 Dalton rule for passive diffusion into the skin, so you practically have to use penetration enhancers. The formula we mentioned used gluconolactone to chelate calcium and temporarily loosen up those skin cells right alongside niacinamide to normalize cell turnover. And here's a massive stability warning. Syn-Ake has an amide bond that is highly sensitive to pH extremes. If you mix it directly with strong alpha-hydroxy acids, like say a 20% glycolic acid sitting at a 3.5 pH, you will rapidly hydrolyze and completely destroy the peptide. So how do we actually integrate this the right way? Let's walk through the optimal daily protocol. To get the most out of that neuromuscular blockade, Syn-Ake needs to go on in the morning on clean, hydrated skin right after washing. You definitely want to avoid putting it over heavy occlusives like petrolatum or dimethicone because those will block it from penetrating. Then, when evening rolls around, you pair it with a structural signal peptide, something like Matricel. While Syn-Ake minimizes the expression damage during your active day, Matricel can stimulate fibroblasts to pump out new collagen while your face rests at night. But consistency is an absolute requirement here. You really have to understand the pharmacokinetics. This is a steady state accumulation process. It's not a 3-day miracle fix. The peptide has to gradually build up in the tissue. So getting those peak clinical results requires some patience and twice daily application for the full 8 to 12-week timeline that we see in the clinical trials. It really begs the question, if we can safely mimic the paralytic power of Viper Venom today, what other secrets is nature holding for the future of longevity? That's all for this explainer here at Peptide Proof. Thanks for watching, and we'll see you next time.